All right, it's all you, Nathan.
All right. Go ahead and start sharing my screen. All right. Well, good morning, everyone. My name is Nathan Traylor. I'm a web developer here at North Point Geographic Solutions. And today I just wanted to talk a little bit about the fundamentals of communication through the internet and what the internet is and using RESTful services, and a little bit about how it can tie into working every day with ArcGIS. So to start off, there's an important question that I'm looking to answer, and that is, what is the internet? And I think that it's safe to say that we all probably know what the internet is. I think we're all tuned into this through the internet, but a formal definition of what the internet actually is and the system that supports the internet, that could be a little bit more of a esoteric knowledge. So it's known as the network of networks. And what that means, to put it simply, is that the internet is a network made up of billions of devices across the world, and they're all talking back and forth to each other. So when you connect to a website, let's say you go to google.com, what's happening is you're receiving a message from another device, and in that message, you're being told what is hosted at google.com. So this interaction across the internet, it essentially could be thought about as devices having a conversation with each other. Now, what exactly are in these conversations? That's the next question that my brain naturally leads to. And before we can answer that, there's another question that we have to answer. And that question is, how are all these devices connected? Now, some of you could already know the answer. Some of you might not. And if you don't know the answer, you might be surprised to find out that all of these devices are all connected through a series of cables that live underground and at the bottom of the ocean. And on the right here is actually a picture of one of these cables being installed. So some proof that it's real. So what happens is when a message starts at one device, let's say you're trying to get to google.com, your device broadcasts this message to another device, and that's called a router. And I'm thinking that we all have one of those in our home as well. And this broadcast is often carried out wirelessly through what we know as Wi-Fi. Now, once the router has that message, it then delivers the message to an ISP through a wired connection. It delivers the message to a ISP through a wired connection. So your router at home, it's connected to the wall, most likely through a special wire to a special outlet. And what's actually going on there is that wire is connecting to more wires that connect to the internet service provider. And once the internet service provider has the message, it then handles all of the communication through those submerged cables and delivers the message to where it's supposed to be going. So at the end of the day, all of the communication through the internet is actually just electricity. It's just electrical signals being sent through these cables in special patterns that are meaningful to some device somewhere. And I think that's pretty neat. So now we can loop back and ask ourselves again, what are these conversations? We know how these messages are distributed, but what are the messages saying? And this is where we introduce the hypertext transfer protocol. It's known as HTTP for short. And this is the protocol used for interacting with non-local resources across the internet. So that just kind of means what language are these messages following to talk to each other. And when I say that you're interacting with non-local resources, I mean that google.com isn't actually hosted on your computer, or it's not something that you can just get from your hard drive on your computer. You have to retrieve it from somewhere elsewhere. And we use HTTP to handle the communication that will allow you to retrieve google.com. So these interactions, they occur between what we know as a client and a server. It's handled at the top layer, the application layer of the OSI, which stands for Open Systems Interconnection Model. And we'll see a little bit more about that layer later, but since that can be a little bit in the weeds of networking material, we won't go too deep into that. And another important thing to note about HTTP is that it's stateless. And that means that no two interactions, none of the two messages being sent will ever be linked to each other. Now, this could be a problem. Let's say if you're shopping on Amazon and you have two different tabs open. If you add something to your shopping cart in one of those tabs, the other tab has to be updated with that. And if it's a stateless protocol, there's not a real way to get that update across all tabs. But we're going to see a workaround for that a little later as well. So initiating one of these communications is referred to as making a request. And something important to note about that is that the client always makes the request. The server is never making a request. It's always the client. Any tool that makes a request on behalf of a user is called a user agent. And this is most commonly the web browser. So Google Chrome, Firefox, Safari, those all act as user agents. Now, these requests are sent as TCP packets. And what a packet is it's the data that's being sent with a request, but it's broken down into smaller bits. And the reason that this happens is because, let's say you're trying to get a 2-hour long movie and you want it in HD. Well, that's going to be a lot of data that has to be sent across those cables. Remember, this is all physical, this is all electrical. So there's only a certain amount of actions that can go on at one time through these cables. And if those cables are all occupied sending one person their 2-hour long movie, no one else will be able to get the data that they need to have sent at that time. And so the data just gets broken down into smaller bits, and then everyone takes turns getting a little bit of data at a time so that it's more fair, more uniform, and everyone can get their data in a faster manner. Now, there's two different kinds of packets that are mainly used. There's TCP packets and there's UDP packets. And the main difference between the two is that TCP packets prioritize reliability, and UDP packets, they prioritize speed. So if you're transferring sensitive information or information where you want to make sure that none of the data is lost, you're going to be using TCP packets. But if you're watching a live stream or playing video games online, something of the sort, and you need fast responses, you're going to use UDP packets. And this is usually handled automatically as well. So servers, they reply to a request with what we know as a response. Going back and doubling down on the fact that clients always make the requests and the servers always send responses. Now, responses, they can contain status codes that indicate the result of the request made, as well as any of the requested information that was able to be sent along. And this is essentially how the internet works. So you enter a URL, you request a web page, and then a server sends that web page in response. And this is kind of where REST comes in. That was mentioned a little bit earlier as well. Now, REST stands for Representational State Transfer. And HTTP requests are made, they're always made out to what is known as a REST API. And what REST APIs do is they define what types of actions a client can make to interact with the application that is hosted at the server. There's a couple different kinds of REST requests that you can make, and they're get, post, put, and delete. So a GET request is used to retrieve resources that already exist on a server. A POST request is used to create new resources on a server. A PUT request is used to update information of resources that already exist on a server. And deleting just deletes resources that already exist on a server. Now, these requests, they also correspond to another acronym, and that acronym is CRUD. Create, retrieve, update, and delete. And if you've ever worked with any databases or you've done any database management work, you probably recognize those. But those are the 4 essential operations that go into database management. Use create, you post, or you create with post, you retrieve with get, you update with put, and delete with delete. So looping back to the OSI that was mentioned earlier, we won't spend too much time on this because it is also a little bit esoteric as well. But what I want to illustrate right here is there's this application layer up at the top. And then all the way down here, this is the physical layer. And what this is that internet cable at the bottom of the ocean that I was talking about. So what happens when you make a request is you start up here at the application layer. You transmit the data through all of these different layers, all the way down to that cable. And your message then travels through that cable all the way up through all those layers back up to the application layer at the other side. And that's how your message gets sent across through those layers, excuse me. Right here, this is a little table of just the different types of status codes that you can get in a response. The most common ones are the 404 not found. I think we've all probably seen that when trying to visit a link at some point. There's also the 500 internal server error. So with a 404, the issue is usually you tried to reach something that doesn't exist. But with a 500, that means that something was going on the server end. And so 404, you're bad. 500, the server's bad. And then the 418 is my favorite one. It's I'm a teapot. There's not a great explanation of applicable use to that one, but it's an old joke from the tech people of the 90s. So with each question and response, they all have different concepts, but they follow this same structure for the most part. And so to start line, and it declares the request on status. So whether or not your request, it tells you whether or not it's went well. Is the block of triggers, and is they're just specifying parameters of the request. different things that you can pick and choose about the request that I'm making. There's a blank line down here, and this signifies the endpoint of the data for the request. Then if the message is a response, you'll see there's a body afterwards. What that body contains is all of the data for the request. And so the start line is known as the head of the request, and the body is also known as payload. I don't really know where the if everyone is a developer or not in here, or if anyone actively codes, but so I tried to steer away from too much code in the presentation, but this is a little example function so that you can see a request happening in action in code. So this little screenshot here, it's using the Axios library, and the Axios library basically just allows you to carry out HTTP requests in your software or your application. So on this first line, you have axios.get, and what this is doing is making a GET request to whatever link you provide right here. And so on the screenshot, there's a GitHub link where the GET request is being made to. In this .then snippet of the screenshot, there's this res, short for response variable. And what that has is all of the data that was included in the response of the request. So once you have this, once you're in this .then, you're then able to get the data from the response and do as you wish with it. And finally, down here, there's this .catch, which is added on. And what this does is if there was an error with the request, or if something went wrong with the response or the request, you can catch that error and then handle that error the way that you want as well. So the next thing I wanted to talk about were cookies. And in this day and age, I'm pretty sure every single website is prompting you with something, some term of agreement that you have to sign off on, saying that they use cookies and you have to allow it or deny it. But there's never really a good definition for what a cookie even is with those. And so we can go through that a little bit now. And basically, what a cookie is it's a small packet of unique data sent by the server to the client in the response. So once the browser receives that cookie back in a response, it then stores it, but it includes that cookie with every single request that it makes back to that same server. And so it's kind of a unique identifier to let the server know that you've been there before and you're a repeat visitor, and it can retrieve any unique information about you specifically. So these are typically used for telling whether or not requests are coming from the same browser, like I said. And this is a little bit of a diagram kind of explaining the process that I was just attempting to illustrate. So you start here on the client side and you make your usual HTTP request to Amazon, and Amazon sees that there wasn't any cookie attached with the request. So what it does is it creates a unique ID for you in its database, and it creates a unique cookie for you. And whatever response it sends to you on the first time, it'll attach that cookie. And then from there on out, every single time that you make a request to that same Amazon server, you're going to attach that cookie. And so that the server knows who you are. And it's basically saying hello again. You can see here that you could even wait a week or a month, or as long as the cookie stays in your web browser, and it'll still stay recognized, and it still gets sent with every single request that you make. All right. From cookies, we can also move on to caching. And the whole point of caching is that retrieving the same data from a website every time you visit it, it can make that network activity load pretty heavy. So if there's multiple resources on the website that you're going to be retrieving every single time, for example, the logo of the website, that's something that could just be stored somewhere, and then you won't have to fetch it from the server every single time. And that's where caching comes in. So the formal definition of a cache, it's a noun, it's a hiding place, especially one in the ground for ammunition, food, etc. Clearly a little bit dated of a definition, but that's where we get the term from, because a web cache works quite similarly. You store data in a cache and you retrieve it at later times without having to communicate with the server. And this improves the speed of the communication substantially. So there's a couple of different types of caches. There's a shared cache, and that's a cache that stores responses for multiple different clients to retrieve at their own individual requests. And then there's private caches, and a private cache is for individual clients, and this is typically stored in your web browser. And this improves the performance of backward, forward page navigation, saving things, offline browsing, things of the sort. So if that didn't make too much sense, hopefully this illustration helps out a little bit with that. Up here, we can see if you don't use a cache, your browser has to go directly to that web server every single time it wants to retrieve the things from that website. And remember, like what I was saying earlier, this is all happening across the world in these wires that are sitting at the bottom of the ocean. And let's say if Google was hosted in Italy and you're in Duluth, Minnesota, that's a long ways that those electrical signals have to travel every single time that you want to retrieve data from that server. And so this is where caching comes in. If you have a shared cache, browsers all can store these resources a little bit closer to themselves, or they can retrieve the information. The browsers can retrieve the information from this shared cache, and it's a little bit closer to themselves. But if it's a private cache, that cache is just stored directly in the browser. And I don't know how much faster you can get than that, saving a lot of time and distance. So the last concept I wanted to talk about before getting into a couple examples is CORS and CORS policies. So this stands for cross-origin resource sharing. And what this is it's another type of headers that gets attached to an HTTP request, and they're used to specify origins that resources are allowed to be loaded from. So by default, resources can only be loaded from the origin server itself. So if you make a request to google.com, you can only get resources from where google.com is hosted. But let's say your website is making use of a font, and that font is hosted on a different server somewhere. You would then have to list the origin of that font in the CORS header to be able to retrieve the font to use in your website. So basically, CORS is just deciding who else can talk in this private conversation. This is all made relevant by the same origin policy. It's an important security mechanism that is used all over across the internet, and it limits the communication between a browser and a web page to the same origin. And this is enforced by the browser. So if you need that font, you have to add that font origin to the course header because it's an outside origin, and due to the same origin policy, you won't be able to retrieve it elsewhere or otherwise. There's another thing that goes with these, and that's called pre-flight methods. And you can use a pre-flight method to define what type of REST request or what type of action can be carried out by that outside origin. So if the origin of that font on that other server, if for some reason you want that to be able to make GET requests, you can define that with a pre-flight method. Here's a couple more illustrations that hopefully can make good examples out of the cores. So right up top here, we have just your standard website link. And you see it starts with the scheme, HTTPS. You have the domain. This one is websecurityacademy.com. It could be google.com. It could be esri.com. Could be facebook.com. And then there's the port. And oftentimes you won't see this on live versions, but that will exist at certain times. And then whatever path extension there is afterwards. So maybe facebook.com/YouTube. But all of these together is what makes up an origin. And that's what I mean about origins of resources. So down here, there's another little bit of a code example. And you see that you're bringing in cores into this code by requiring this cores library. And you're telling the app to use this cores policy right here. That's basically a pseudocode way of explaining what's going on. But in this cores method, you're defining the origin of this link right here. It's just a localhost link in this example, but then you're also defining the pre-flight methods of get and post. And so what this is doing right here is you're telling the app that this origin can also enter the conversation, and it's allowed to do get and post requests. Now, if you are a developer and you have worked with JavaScript development or any web development before, the chances are you've probably run into this error on the right screenshot here. This access to XML HTTP request at blah, blah, blah has been blocked by cores policy. And the reason that you're getting that error is because you're trying to retrieve data or access a different origin than what is allowed and what is the true origin of the application. So to get around this, you have to define whatever origin is causing the error. You have to define that in the cores policy, and then it'll be attached in all of the cores headers, and you'll be able to work with it from there on out. So I have a few request examples prepared for this. They aren't going too deep into it, but they're good examples of seeing what happens with this request flow. And so I'm opening up, this is Postman. This application is Postman right here. If you're not familiar with it, it's a nice developer tool, and it's basically just an application that lets you try out different requests, different headers, anything that goes with communicating across the internet, and you can test them out and see if they fail or they pass and see what data comes with them. And so what I'm doing right here is I have this google.com link right here, and I have the request type set to get. And so in here, you can see I have this headers section as well. And what this headers section is defining is just all of the headers that would get attached with the request that I'm about to make to google.com. And so when I run it, you can see that I got in here, I have this status of 200 OK. And what that means is the request went through just fine, and I got my data and my response back just fine, and there weren't any detectable errors. Now, this just looks like a huge block of jumbled code that is hard to make any meaning out of. But if I go into preview here, you'll see that I got the google.com homepage. And so this is another good illustration of just how the internet works. You type in a URL, you make a request, and you retrieve the website in a response. And so here I have google.com/this is a bad request. And if you can guess what is expected to happen from this is it's supposed to not work. So if I hit send here, I'll see I have this status of 404 not found. And I think it's a little misleading that this text is green. If it were my choice, I would make that text red. But this status code means that there was an error on my side of whatever I was trying to access. If I hit preview here, you can see that I got that landing page that Google has for all of their 404 errors. And we can also see this in the web browser as well. So over here, I have this new tab open, and I have it just for google.com. So if I open up the inspect element tool and go over to the network tab, if you don't know what this is as well, this is just this is a tool that's built into Google Chrome, and you can actually track network activity just like this here in Postman, but you can do it right in Google Chrome. So if I go to google.com and I hit enter, you'll see all of these requests that just came through. And at the top here, you'll see this main request for google.com. And you'll see all of these are the headers that were attached with the response. And you'll see some of these cookie headers as well that we were talking about earlier. But then you'll also see the same request headers that you were seeing in Postman earlier over here. And so looking at this further, you also see I got that status code of 200, which means that the request went through just fine. With this, we can try google.com/this is a bad request and see what this one looks like. So if I try to go to this one, you'll see that request was now red text, the way that Postman should be doing it. And it has that 404 not found error. If you look in the preview here, you can see you're getting the same thing that you're getting over here. And if you look at the preview and the good one, well, it doesn't look too elegant here, but it's supposed to be google.com. And this can, I was saying earlier that this is directly applicable to working with ArcGIS. And so if you look right here, so there's this feature layer that's from Esri, and you can open it up in the map viewer and look at all these different data points across the world. And I just picked this layer. It's an Esri one, a standard one that's on Living Atlas. Just has some data of potential fires and such. And you can click on something and see all the information that's attached with whatever feature you just clicked on it. And all of these features, they live over here in this REST endpoint. So if you've worked with any of the REST services with ArcGIS, or if you've had to do any data management with ArcGIS, you might recognize this kind of page right here. There's this is the feature layer, the endpoint for the feature layer. And it has all of the information about this feature layer, including the extent, the rendering info, the fields of the objects, the field names of the objects in the feature layer. And you'll also see down here that there is the query operation that is supported with this feature layer. So over here, you can perform queries on the feature layer and retrieve certain objects or certain information about the feature layer through this page. And so it supports SQL-like clauses. So you can add a where clause in here, and you can define the outfields with a star if you want to retrieve all of the outfields from the feature layer that you're trying to query on. And you can also define which object IDs you would like to query on. So let's say you just want to get the first object in this feature layer. You can just say you want object ID of 1. You can add that star in the outfield, and then you can do query. And you see right here in parentheses, it says get. So that means that you're making a get request to the REST service. Once you click that, you can see at the bottom here, you have that object ID of 1, and then you have all of the fields and all the data in the fields for that object. So pretty neat. And you can also see, while we were talking about origins earlier, you have the schema, and you have the domain, and then you have the extension over here. And at the end of the extension, you can see for this feature layer, this link goes all the way out to where there's feature server /0. But over here, after we've done this query, you see that we're in feature server /0/query, followed by a question mark. And then all of this text from here on out at the end of this link is just specifying the parameters that you set in this query. And so if you go back here and you do another query, and actually, if you want to look at that back in the same networking window that's opened up in the Chrome Dev Tools, you can define your object ID as 1 again, and you can give yourself all of the outfields that you want. And once you make that GET request, there you are. You can see that request right here. And you can see this entire page is included in that preview. And you can see the payload. You can see all of the data that came in the response. And you can see that link that you were making the request with and the status. And so if you're ever having any issues where you're not getting any of the data that you're looking to get from your feature layer, or your pop-up isn't getting the right kind of data, or issues of the sort, this is a really good way to try to figure out what's going on by going in and finding this URL and literally just copying and pasting it and seeing what you get when you try to visit that.
Ismael just called me. He's like, hey, is Mike there? And I said, he might not be there, but you can go. But he canceled. He said, it could be something different than the roof.
Yeah.
Michael,
Yeah,
you might be off mute right now.
Because, I mean, we patched up the roof.
There, I muted him.
Okay. Well, no worries. I'm actually towards the end of the presentation now. So I hope those were some helpful examples that were able to illustrate some of these concepts a little bit better. And in conclusion, just to wrap things up, use network requests to interact with software and machines that aren't local. Check the network activity in the browser if you aren't getting the data that you're expecting. Cookies, they're used to maintain the state of a stateless protocol. Caches, they're used to improve communication speeds. And use CORS headers to allow other origins to be trusted by the same origin policy. And there's a little informal works cited if you're interested in viewing any links and learning more about this stuff. That'll wrap it up. If
Awesome.
excuse me, if you have any questions or comments or anything, I'll take those now.
There aren't any in the chat. Awesome. Well, that was super interesting. Thank you so much, Nathan.
Thank you.
All right, I'm going to stop recording.